guys, so we have moved on to chapter 3. And our question is, how did the Mesosaurus fossils on the South American plate and the African plate get so far apart? So in chapter 1, we found out that Mesosaurus fossils are found on hard, solid rock that underneath the surface of Earth of like sand and water and vegetation, that all of Earth's surface is basically hard, solid rock. And we found out that the South American plate, that the fossils are on the South American plate and the African plate. They're on two different plates, and that these plates meet at a divergent boundary. And that means the plates move apart, just like this. They separate. And there's two possible answers or two possible claims to this question. Let's take a look at them. Our first claim is the South American plate and the African plate moved apart suddenly. So that means that they were once together and they suddenly moved far apart. So that means they moved apart in a quick fashion. Claim 2 is saying that the South American plate and the African plate moved apart gradually. So that means the plates were once together and it took a long time for them to separate. So today, after this part, you guys are going to be exploring in the simulation and gathering evidence to see whether claim 1 or claim 2 is supported. And that's like how scientists really work. There's possible claims or possible hypotheses to a question, and basically scientists do experiments or investigate to figure out where the evidence supports. So, investigation question today is, what do we know about plate motion that is currently taking place? Okay, so far we have learned in this last chapter that at all boundaries or earth divergent and convergent boundaries, that there's earthquake activity happening and volcanic activity happening. And we also learned that scientists are able to learn more about plate motion and the rate of plate motion with GPS systems. And we learned earlier in this lesson that GPS basically stands for Global Positioning System. And that in the system, there's a receiver and there's a satellite. So scientists basically place GPS markers or receivers along plate boundaries, which calculate how far the plate is moving. Okay, so basically they put into many different rocks along the plate boundaries on both sides, and they use a satellite to calculate how far the plate has moved in a certain amount of time. The system is so much more reliable than having a scientist go and like mark a rock with an X and with red marker or paint, and then go back in a certain amount of time to just take a ruler and measure. So much more reliable than the system that I'm talking about. So basically, it tells the rate of plate motion. It measures the rate of plate motion. And what I mean by rate is how often or how fast something happens. So let's take a look at rate in two other scenarios that we're familiar with. So here is a picture of a speedometer of a car. And notice the speedometer is in kilometers an hour. So this is a speedometer of a car that is not in the US. It is moving about 108 kilometers an hour. So that means for every hour, it moves 108 kilometers. So pay attention, that is 108 kilometers an hour. It's an average. So on average, this car is moving at 108 kilometers an hour. Over here is a nurse taking the pulse of this patient, and an average pulse could be 75 beats per minute. So that means for every minute, this patient's heart beats 75 times. So it is an average of how often or how fast something happens. Another thing you should notice is rate. There's two measurements involved. It is for speedometer, it's a distance and a time. is usually something versus time. So over here it's beats per minute, and over here it's kilometers per hour. And the way to say per is division. It's that division sign, kilometers, and if you notice in the speedometer, there's a slash, and the slash means division. Now let's connect it back to plate motion by looking at this plate movement map. On this map, you see the red lines that represent the plate boundaries that we've been talking about. But you also see a lot of decimal numbers. These decimal numbers, according to the ski, tell you the rate at which plates move per year. And the numbers, the measurements are centimeters per year. So, for example, let's take a look at this South American plate that we've been seeing a lot. So, over here is saying that the South American plate is moving towards its Nazca plate at 10.1 centimeters per year. And let's take a look at the rest of the map. That you see not the same number for rate. You should be noticing that around the world, these plates move at different rates. Over here, the Eurasian plate is moving 1.8 centimeters per year away from this North American plate. Today, after this part, in part 3, you are going to take a look at the simulation and gather your own your own data to figure out rate yourselves of the plates and how much they move in a certain amount of time. So let's take a look at rate again and how we actually calculate it. So it's distance divided by time in terms of rate. So, for example, 500 kilometers divided by 50 million years. Doesn't matter if time is a big amount of time, time is always that second number you divide. It's distance divided by time. So 500 kilometers divided by 50 million years. It's always this order. Order really matters. So distance divided by time is how you get rate or how you get speed that we learned earlier. Here's an example that we can practice on. So here's a map of a trip that my husband and I had taken many years ago before our children were born. We went to California, we stayed in Santa Monica Beach, and my husband is a diehard Yankees fan, and he found out Yankees were playing the Dodgers, and we wanted to go see a game. So we put in our GPS of our car, a rental car that time, and it said that it would take 40 minutes for us to get to the stadium. And take a look at this red. This red means there's a whole lot of traffic in LA area. And it was to get to 14.7 miles. Okay. So all you have to do, rate again is distance divided by time, is you take the distance, 14.7 miles, divide by 40 minutes equals 0.37 miles per minute. That slash means per. Okay. Remember your measurements. When you are labeling your numbers, you have to label the distance divided by that time. So we use miles, 14.7 miles. We divide by 40, and we got 0.37 miles per minute. And it's also very important that when you do this, you're not doing mental math. You need to use the calculator. You need to go in a new tab in Google Chrome, search for a calculator, and type in 14.7 divide 40, and you get a long decimal number. When you get that long decimal number, we want to shorten it to something reasonable to read. And to do that, we like to round our numbers to decimal places. So, or basically the tenths and hundreds to the hundredth spot. So 0.37 miles per minute is a reasonable number to write down, not the whole entire long number. When you round your numbers, round it 2 decimal places over. So after this little video, on the next slide, you have your own practice problem of figuring out rate, and then you move on to the simulation to gather evidence about plate motion and figure out the rate of plates. See you guys later.